systems of equations, we are still finding where two lines intersect. We're just doing it in a slightly different way. So I'm going to write down our steps for solving by substitution. When we solve by substitution, we solve one equation for x or y. So we get x or y by itself for one equation. And usually the way we decide is we pick the easiest one. We plug that in to the other equation. So we'll have something like y equals 3x plus 5. We plug that into the other equation. Plugging in is the same as substituting. We plug that into the other equation. And then we can solve for the value of that variable. So we can solve that equation and get x equals 5, for example. And then once we do that, then we can plug that in to either equation to find the other variable. And we just, to solve by substitution, we always follow these steps. And we call it substitution because plugging in is another word for substitution. All right, so I just want to look at some examples. So on all of our examples, we're solving by substitution. We have y equals 5x, and x plus y equals 12. Now, when we're solving equations, a lot of times people have a favorite way of solving equations. But on your test, there will be problems that ask you solve by substitution, solve by graphing, etc. All right, the computers, please, let's put them away. I'm going to write these in two different colors just to make it easier to separate. So I have y equals 5x. And x plus y equals 12. Well, this first equation already has y by itself. So we don't need to do anything to this. We have y by itself. That's always a good thing when we're solving by substitution. Now I'm going to take this value of y. It says y equals 5x. And I'm going to plug it into the other equation there for y. So when I do that, I get x plus 5x equals 12. So I plugged in 5x for y. Well, now this becomes, I'm just going to change because we just have a normal equation now, 6x equals 12, divide by 6, and I get x equals 2. And I can plug x equals 2 into either equation to find y. So let's say I take x equals 2. I think the easiest would be to take x equals 2 and plug it in right there. When I do that, I get y equals 5 times 2, which is 10. So my solution is the point 2, 10. X equals 2, y equals 10. Yes. 4x plus 5x is 6x. And I can check my solution. 2 times 5 is 10, and 2 plus 10 is 12. I can plug into both equations, and it makes both true. All right, questions there. Okay, let's look at another one. 7x minus 3y equals 2, and minus 2y plus x equals negative 6. And we want to solve by substitution. Now we don't have x or y by itself in either equation. So looking at these, which equation do you think would be easiest? And I'm going to rewrite these in two different colors. 7x minus 3y equals 2, and my green equation, minus 2y plus x equals negative 6. Which of these do you think is going to be easiest to get either x or y by itself? The bottom one, because this is just an x, so if I get rid of this negative 2y, I have x by itself. So I'm going to add 2y to both sides here. In my green equation, I get x equals negative 6 plus 2y. Now I have x by itself. And now I'm going to take this, and I'm going to plug it in here into the other equation for x. So my blue equation then is 7 times, in parentheses, negative 6 plus 2y. I'm multiplying that whole thing, minus 3y equals 2. So I took this whole thing and plugged it in for x. Well, now I need to distribute. 7 times negative 6 is negative 42 plus 14y minus 3y equals 2. And now we're back in chapter, what was this, chapter 2 when we were doing this? 14, I need to combine my like terms. 14y minus 3y is 11y. So I have negative 42 plus 11y equals 2. Add 42 to both sides. And I get 11y equals 44. Divide by 11. And I get y equals 4. And now I can plug this into either equation to get x. I think the easiest here would be to take this y equals 4 and plug it in right there, because I have x equals something there. So when I do that, I get x equals negative 6 plus 2 times 4, which is negative 6 plus 8, which is 2. So we get y equals 4 and x equals 2. So my solution is 2, 4. X is 2, y is 4. Yes? Either of the original equations, yes. And I chose this one because it had x by itself already, so when I calculated, I would get x equals something. But either one will work. Now there's a fair number of steps here, but they're all steps that we have practiced doing for several chapters now. All of this is just combining like terms. solving equations, all stuff that we've been practicing since the beginning of school. All right. Any questions? Okay, let's look at a word problem. Our favorite. So let's say a store sells shirts for $8 and hoodies for $12. It's a good price for both of those. Last month, they sold 37 shirts and 37, I'm going to say products, 37 total products for $376. We want to know how many shirts did they sell. Well, let's let X equal the number of shirts and Y equal the number of hoodies. The problem tells us they sold a total of 37, so X plus Y has to be 37. They sold a total of 37 things. And they made $376. Well, the amount that they get from shirts is 8 times X plus the amount they make from hoodies is 12 times Y. And that equals 376. Those are my two equations. I would say the first one is easier to solve for either X or Y. And I chose to solve for X just because. So if I subtract Y from both sides for that first one, I get that X equals 37 minus Y. And I'm going to take that and plug it into the second equation right there. So I'll get 8 times 37 minus Y plus 12Y equals 376. And now we're doing the same process we did in the last problem. I distribute 8 times 37 is 296 minus 8Y plus 12Y equals 376. Combine my like terms, negative 8Y plus 12Y is 4Y. Subtract 296 from both sides. I get 4Y equals 376 minus 296 is 80. Divide by 4. And I get Y equals 10. No, 20. And now I can take Y equals 20 and plug it in right there. And I get X equals 37 minus 20, which is 17. And there's my answer. We sold 17. We sold 17 shirts. Sorry. And we sold, is that, what did the question ask us? How many shirts? 17 shirts. And we sold 20 hoodies. questions there? Solving by substitution, always the same, every single time. Solve one equation for x or y, plug it into the other equation. You'll get one variable. Take that variable, plug it into either one of the first equations to get the other variable. The same steps every single time. All right, let's talk about our special cases. When we solve by substitution, sometimes it will happen that you end up with something like 0 equals 0 when you plug one thing into the other equation and simplify. Or you get 5 equals 5, etc. To get something equals, a number equals a number. Do we remember what this tells us? This is always true, so how many solutions do we have? When we get something that is always true, we get an infinite number of solutions. And when we get an infinite number of solutions, what that's telling us is that those two equations are the same line. So if we graph that system of equations, we get two lines right on top of each other. 0 equals 0, 5 equals 5, something that's always true is an infinite number of solutions. Our graph would be the same line. Our other special case, sometimes we'll solve our system of equations and we'll get something like 2 equals 0 or 5 equals 7. How often is that true? This is never true. That tells us we get no solutions. So we solve one equation for one variable, plug it into the other equation. We do our combining like terms, etc., and we get 5 equals 7, or 2 equals 0. That tells us we have no solutions. If we graph those two lines, that tells us the lines, do we remember, are, when we get no solution, they never touch. So what's the fancy word for that? Parallel. They're parallel. The lines are parallel. Never touch is definitely the way we could think of it. They never intersect. And I guess we could think of these as they always touch in every single point that they have. All right, so when we get these things, something is always true. That tells us we have an infinite number of solutions. When we graph the lines, they'd be the same line. When we get something that's never true, we have no solutions. That means the lines are parallel. They never intersect. And sometimes it's easy to see when you look at the equations that you're given, to see that you have an infinite number of solutions or no solution. Because an infinite number of solutions, you have the same two equations repeated. You get no solutions if you have the same slope but a different y-intercept. So sometimes you can look at the equations and see that. If you put them both in y equals mx plus b form, it's pretty easy to see. All right. Questions on solving by substitution? Okay, our homework today is a worksheet, and we will work on, I should put that on the board. We will work on the odd problems today again.